Thanks. My name is Jess. This is a project that I've been working on with Min and Kyle, who are also both Jupyter developers. Min is also at Berkeley, and Kyle's at Rackspace. So before I dive into the talk, I have... my thing isn't working. There we go. If you can go to this link, this is going to take you to an Etherpad, and if you want to put your GitHub username there, at the end of the talk, I will add all of those usernames to the demo server that I'm going to be showing, and so you can actually log in and play around with stuff yourself if you want. And I also tweeted this link, so if you go to my Twitter feed, which is @jhamrick, or you should see it on the SciPy 2015 hashtag, you should be able to find this link to the Etherpad. And also, before I get into the talk, some of the stuff I'm going to be talking about today, I wrote in more detail in a blog post. So if you like the talk and you're interested in more of the nitty-gritty, you can go and check out this blog post. And if you just Google for Rackspace JupyterHub, it'll probably be the first hit. In this talk, I am going to tell you a story about how I started teaching with Jupyter Notebooks, and how this led to me building a tool called NBGrader to actually grade those notebooks, and then how this ended up turning up into this massive deployment of JupyterHub for 200 students. And it starts with the fact that I am a teaching assistant for a class called Computational Models of Cognition, or Comp Models for short, since the full title is a bit of a mouthful. And in this class, we teach students about mathematical models of human behavior, and we sort of go through a history of different models that have been proposed and their strengths and weaknesses and so on. And the assignments that students have to complete are programming assignments, and they have sort of the following general structure, where we give them some background material on the particular model that they're dealing with. We give them some instructions and examples of how the model is supposed to work. We then give them a coding exercise where they actually have to implement the model. Sometimes there's some code to create a plot and visualize the results of the model. And then there's also usually a written interpretation of the results, where they actually have to think about what the results mean and whether the model's any good or not. And the class used to be taught in MATLAB, and the original assignments, we just distributed them as zip archives. And these included a PDF with some instructions, some MATLAB files, and some text files for them to write their written responses. And the problem, though, is that these original assignments had a number of issues. For example, there were often inconsistent instructions between the PDFs and the MATLAB and text files, and this confused students. We had to maintain two separate versions, one that had solutions and one that didn't, and we would sometimes make a change to one of these versions and forget to change the other one, and then we would release the assignments with bugs in them. We had issues with encoding when students would submit the text files with their written responses. They had a bunch of different encodings that we had to deal with. People would sometimes rename the files, or they would forget to submit files. And auto-grading in MATLAB is really hard. I had a lot of issues getting that to work well. So it really was not a very pleasant grading experience. And the assignments, I think, were also frustrating for the students. So I wanted to figure out a way to improve these assignments and make them better, and also improve the grading workflow. And I personally love Python. Python is awesome. So I thought, well, maybe we can rewrite the assignments in Python. That'll help with the auto-grading. It'll maybe also make it a bit better for students who are coming in now having taken Intro Computer Science, which is now taught in Python at Berkeley. And also, if we use Python, then we can use Jupyter Notebooks, and Jupyter Notebooks are awesome because they actually give us the perfect format that we need for these types of assignments, where we can have instructions, examples, code, plots, written responses, all in the same document, and students don't have to deal with multiple files. They can just work in one place and see everything there. It also is nicer for grading because you can, as you're grading written responses, you can scroll up and look at what code they wrote, what plots they generated, etc. So I was all excited about using these for assignments, but then there's a question of how to actually grade the assignments. So, in traditional programming classes, you have a script, you run your script against the auto-grader, and it tells you whether it's passed or failed. With notebooks, it's not quite as straightforward because you might have multiple problems within the same notebook. You can execute notebooks, but it's not really quite the same as executing a script. So there's some issues there with figuring out how to do that. So to solve this, I started working on this project called NBGrader about a year ago. It stands for Notebook Grader. And over the past year, it sort of evolved into this suite of tools for creating, releasing, collecting, and grading assignments. And it's been used in a couple of classes, mine and a few that Brian Granger has taught. And it's been working pretty well. So I'll show you just a short example of what one of these assignments might look like. So this is actually an assignment from the class that I taught this spring. At the front, we have some background material about the model that we're dealing with. We have some examples, we have some instructions for what they're supposed to do, and then there's a coding exercise where they have to write their code here. And then we give them a cell with some test cases where they have to write the code so that these test cases pass. Then there's another coding assignment, and then down a little bit further, we give them some particular inputs to run their code on. They get the results, and they have to write a written response interpreting those results and thinking about them a bit. So that's how these assignments typically work, and it's really nice. This type of assignment structure works really, really well. However, there's still challenges even with that. For example, the students in our class, about half of them have about a semester of programming experience and probably haven't seen the command line before. And running the Jupyter Notebook requires launching it from the command line. Even if we get Jupyter installed just fine, it's going to be difficult to ensure that everyone has the same version of all the different libraries that we need. If we need to update a version of a library in the middle of the semester, which we did have to do with Matplotlib, that's going to be hard to do if everyone has it installed on their own machines with different operating systems. We'll still have this issue of students submitting their assignments incorrectly, maybe renaming files or forgetting to include files. This class has over 200 students in it. So, while some of these issues might be not as big of a deal if you're dealing with 20 or 30 students or maybe even 50 students, with 200, it's going to take a ton of time to deal with all of these installation and versioning issues. So, I was really excited about the notebook, but there were all these challenges. And so I was at the IPython dev meeting last September, and I was talking to people about how I wanted to use the notebook for my class, but all of these things. And Min and Kyle convinced me that I should use JupyterHub. And JupyterHub is a service that essentially allows you to authenticate users. And then once the user is authenticated and logged in, it launches them their own personal notebook server, but it's on a remote server. So they don't have to install anything. They just have to go to a website, and they can work on everything there. And this is nice because it is cross-platform, and it allows us to maintain exactly the same environment for all the students. We can update software in the middle of the semester if we need to, and it's really easy to collect and distribute assignments because we can just copy them to the server or copy them off of the server for grading. However, at the time, JupyterHub was still a very, very new project. It had literally just been created. So we had several challenges that we really needed to address before this was going to work well for the class. In particular, scaling it to this many users was going to be tough because unless you have a really, really big server, you're not going to fit 220 people on the same server. So we needed to figure out how do we make it so JupyterHub can spread across several different servers. We also wanted to have some isolation of the user notebooks because we didn't want students to be able to read each other's notebooks, and we also wanted to make sure that there was some small level of security. But if we're isolating the user environments and we're launching the servers on all of these different machines, we need to make sure that students still have access to the same files regardless of when they log in or on what machine they end up in when they log in. So, long story short, the solution to this is Docker plus NFS, though there's other ways you could probably do it too. Docker is a service that's kind of like a lightweight VM. So you can run processes inside what's called a Docker container, and those processes are isolated from other processes running on the machine. And then NFS is the network file system, and that allows you to have files on one server, and then they get mirrored across other servers, and then when a change is made to those files on any of the servers, it gets propagated to all the other ones. So before I get into more detail about that, I'm going to give you a quick demo of what this actually looks like. So, so you won't be able to log in yet. I will do it at the end of the talk, and then you'll be able to log in and see. But so here, I go to the URL, which is compmodels.tempnb.org. I can sign in with GitHub. This will ask me to authorize the application, and I can click authorize. And now I'm here on compmodels.tempnb.org, and I can click my server and get a server, a notebook server. There's not too much here now, but we have configured this server specifically with mbgrader. So if I go and open a terminal here, I can type mbgrader fetch coxi 131, which is the actual course name for this class, problem set 0. And this is going to download for me problem set 0 for the class. And so now if I come back to the notebook list, I have problem set 0 here. I can go in the directory and see all of the different notebooks. And I'm not going to go through these because I don't have time. But when I add your names later, and you can log in and check these out yourself and play around with them. And this is actually the first assignment. We really did give them this assignment. It's mostly just an introduction to the tools that we used rather than actual course material. But. OK, so that's the gist of how it works. And so students just log in, they get their server, and they can work on their files there, and it's super easy for them. So a very high-level overview of how this actually works is that we have two servers, or two types of servers, sorry. One is the hub server, and that's kind of the main server. And then we have a whole bunch of node servers. So when we did this, we had 7 node servers. And so the user comes to compmodels.tempnb.org. They first encounter JupyterHub, and JupyterHub has 2 components to it. The first is the authenticator, which then goes and talks to GitHub and says, hey, GitHub, is this person who they say they are? And GitHub says yes or no. And then if the answer is yes, JupyterHub then uses the spawner to actually launch the user's notebook server. And this particular spawner that we used talks to a service called Docker Swarm. And Docker Swarm acts just like normal Docker, except whereas normal Docker will only launch containers on one machine, Docker Swarm knows about a cluster of nodes and will launch containers on one of those particular nodes. So it launches the notebook server there. And then this process repeats. Whenever someone comes and logs in, they go through the authenticator, then the spawner, then Swarm starts them up a notebook server, so on and so forth. And so to ensure then that regardless of which node server the notebooks got started on, that they always had the same files, we ran an NFS server on the hub server. And then each of the node servers was running an NFS client with the home directories of all the students, so we could just mount those files within the Docker containers, and they would have access to everything that they needed. So that's a very high-level overview. Again, if you are interested in more detail, you can come talk to me or check out the blog post that I mentioned earlier. So to take a step back and sort of say, how well did this work? Well, I think it worked really, really well. I think it was a huge success. It was really nice having identical environments for everyone, not having to worry about installation issues, being able to carefully make sure that everyone had the right software that they needed. And I think that the format for the notebooks really was much, much better than how the assignments were before. I think the notebook format for assignments works really, really well, and I really think other instructors, if they aren't already using notebooks for assignments, should be using notebooks for assignments. Of course, nothing is perfect. Writing these types of assignments is actually really hard. To write test cases that actually catch all of the errors that students might make is really difficult, and I think it's much harder than writing normal test cases for code. And additionally, there's always you never want to have a single point of failure with a system, but we did. I made the mistake of putting all of the files for the students on just one server, the hub server, and that was a bare metal server, so those files were just directly on a hard drive, and there was no redundancy, no RAID. And this is a problem when the hard drive crashes completely during the final exam. That was pretty terrifying. Me and Min and Kyle sort of were scrambling around trying to fix everything. It took about 5 or 6 hours while everything was down for us to redeploy everything and get it all running again. Moral of the story is Don't let that happen. But, but I mean, it actually highlights something, which is, I mean, I'm not a professional sysadmin. I think I did a pretty good job of setting everything up, but it's hard to cover all of your bases when that's not something that you're, paid to do. So that is sort of one of the drawbacks, is you have to kind of, you have to have some idea of how to deal with these sysadmin issues. So that's it. I think it went really well. I want to thank everyone who's been involved with the project, so Min and Kyle, everyone who has been involved with NBGrader as well, so Brian and John and Matthias have all contributed substantially to NBGrader, the rest of the Jupyter team, to the other teaching assistants in the class and my advisor for putting up with doing all of this conversion to Python and doing this complicated setup, and the students in the class for also putting up with having this experimental format. Also, of course, to SciPy for giving me the opportunity to give this talk. And one last note before I end is that if you liked this talk and you want to talk to me more about Jupyter, JupyterHub, education, whatever, we are having a Jupyter and education BOF that's on Friday from 1 to 2 p.m. in room 204, this room. And there is also just a more general Jupyter and IPython BOF, and that's on Friday from 5:30 to 6:30 in the grand ballroom. Thanks. Questions? The link to the Etherpad. So this one? Sorry? Can you add people that are in the Etherpad? Yes, I will also add people to. Okay, everyone who put their username in should now be added, yes. With working with what, sorry?
Working with non-programming problems, so maybe having, I can't massively respond to it, so numeric or with like just kind of other non-programming maybe bookwork is also integrated with the whole side.
Yeah, so I haven't thought too much about multiple choice questions, though I think you probably could do something cool with that, especially maybe with like IPython widgets. Certainly for, yeah, I mean, us having the written responses was a really big driving factor in this, because that was a really important part of our assignments. And I think, I mean, they're pretty simple right now. It's just write some stuff, but they could easily be expanded to, more specific types of questions, I think. Yeah. Yeah.
I know that SageMath Cloud is trying to solve similar problems. Have you played with that, and what are the differences, and why would you use that system?
I've played with SageMath Cloud a little bit. One thing that I like about this particular setup is that I can, I have a little bit more control over the file flow with NBGrader, being able to collect and download assignments. You don't have that kind of control quite so much with SageMath Cloud, I think. So, yep.
So this beautiful stuff, right, that I can imagine lots of people want to use it, but I can also imagine the vast majority of faculty who just want to teach their class, let's say, would not have the IT know-how or access to IT people who are willing to develop this stuff. So is there a plan to make this sort of more turnkey?
Yeah, that's a really great point. There are people at Berkeley who are trying to get stuff like this set up for more general purpose use at Berkeley, also at Cal Poly, and I think other universities are interested in doing that well and having a little bit more institutional support with it. In terms of a more general purpose case just for everyone, I think it's going to be hard to do that because every school kind of has their own desires for how to do authentication and how users' files are stored and stuff like that. But I really hope that going forward, we will see the setup becoming easier and easier for people to use so that you don't have to be a sysadmin to set it up. Yeah.
Okay.
Oh,
So we're up for time, but if you want to ask that question while Yannick's setting up,
Sure,
then
yep.
maybe.
Absolutely.